Good evening, everyone. We're just going to go over a couple more factoring examples that use some of the combined methods from those video notes. So this problem, x to the 7th minus x equals 0. The first thing we want to do is, since we have an x in all of the terms, we're going to factor out that common x. So we get x times x to the 6th minus 1 equals 0. So from that lonesome x, that already gives us one of our answers. That tells us x equals 0 as a solution. So now we're just left with solving this 6th degree polynomial equation. So in this specific case, both the difference of squares and the difference of cubes formula would apply, because x to the 6th minus 1 could be thought of as x squared to the 3rd minus 1, or x to the 3rd squared minus 1. It's easier to factor it as a difference of squares because that breaks it into two things with two terms instead of a thing with two and then a thing with three. So using our difference of squares formula, we know that x to the 6th minus 1 is going to factor into x cubed minus 1 times x cubed plus 1. And then each of those is now, the one on the left is a difference of cubes, and the one on the right is a sum of cubes. So again, using those formulas, the difference of cubes is going to factor to x minus 1 times x squared plus x plus 1. And then the sum of cubes portion, so this went to this, and then the sum of cubes portion, that's this part, is going to go to x plus 1 times x squared minus x plus 1. Right? And now we just need to solve each of those individual parts. So this is going to tell me x equals 1 as a solution, and this tells me x equals negative 1 as a solution. To solve this, I'm going to use the quadratic formula. So that's x equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 1 all over 2, which will break into negative 1 plus or minus I square root 3 over 2. And then notice this is actually the same as the one over here, but with a plus x instead of a minus x. So if you do the quadratic formula, and you'll see, but it comes out to the same answer but with a positive 1. So we have 1, 2, 3, 4, 5, 6, 7 answers to our original degree 7 polynomial. And this one required, so we factored out a GCF at the beginning, then we used the difference of squares, and then we used the difference of cubes and the sum of cubes. So over here was difference of cubes, and right here is sum of cubes. Sorry, I just made this paper a giant mess. Anyway, this second problem, this one I really just threw the entire kitchen at you. But when you start a problem that's this hideous, your first bet is the only thing you can try if it has more than 3 terms is to see if something groups together nicely. So since we have 1, 2, 3, 4, 5, 6 terms, the easiest thing to start with is see if maybe, just maybe, it will group into 3's. So I'm going to look at my first 3 terms and then my second 3 terms. And why not? Let's just try to factor out the GCF. So from the first 3 terms, I'm going to factor out x cubed, because that's the biggest common thing to all the terms. So if I factor out x cubed, I am left with x to the 4th minus 9x squared plus 8. All right, and then for my next 3 terms, the greatest common factor is going to be a negative 8, right? So because of this constant term, not all the terms have an x. So my best bet is to factor out just a negative 8. So negative 8 times x to the 4th, and then 72 divided by negative 8 would be a negative 9x squared. And then negative 64 divided by negative 8 would give me a plus 8. And like magic, or like your math teacher wrote this problem intentionally to work, we get matching groups. So this part is the same as that part, right? So that means that it does factor nicely by grouping. Now, if we didn't get the same thing there, we would be SOL and have to try something else. So we got x cubed minus 8 from here, x cubed minus 8, and then the other part was x to the 4th minus 9x squared plus 8. So the x cubed minus 8 is conveniently a difference of cubes. So at this point, let's go ahead and split our factors into 2 separate equations. So x cubed minus 8, we'll start with the easier one. This one is a difference of cubes, right? X cubed, and then that's 2 to the 3rd. So this is going to be x minus 2 times x squared plus 2x plus 4. So from this we get the solutions x equals 2 and x equals negative 2 plus or minus square root 2 squared minus 4 times 1 times 4 all over 2. And that's going to end up simplifying to negative 2 plus or minus, that's 4 minus 16 2i root 3 over 2, which is all simplified negative 1 plus or minus I square root 3. So there's 1, 2, 3 solutions. We started the degree 7, so we have to get 4 more. So now let's look at this second part. So this guy is going to be a quadratic form because we have 3 terms and the exponents go down by a half. So the first term is x to the 4th, the second term is x squared, and the third term is a constant. So that's simple that we could use a quadratic form on it. So we'll say that u equals x squared. So then this first term is now going to be u squared, because x squared squared would be x to the 4th. So u squared minus 9u plus 8 equals 0. And this one is now easy to factor. We need numbers that multiply to 8 and add to negative 9. So that's going to be u minus 8 and u minus 1. And then we could set each factor equal to 0. So u minus 8 equals 0. And u minus 1 equals 0. And now we can substitute back in. So u is equal to x squared all along. So now we're going to solve x squared minus 8 equals 0. x squared minus 1 equals 0. So don't forget your plus or minuses, but x squared equals 8, so then x is going to equal plus or minus 2 square root 2. That's just simplifying square root of 8. And here we're going to get x equals plus or minus 1. So that's 1, 2, 3, 4 more solutions, plus the 3 you already had, so that is 7 solutions to this behemoth of a factoring problem. But notice, once you identify the methods you need, there's really no other tricks to these. So as long as you're comfortable using the difference of cubes formula, the grouping, and the quadratic form, these problems don't really get too much trickier once you know all the possible methods.